Now this illustration deals with taps not over 25 foot long, but they're over 10 foot up to 25 foot in accordance with 240.21 B as in boy 2. Now notice if it's a transformer, then we give you the figure loop and see figure 20-17. If you're tapping off of the secondary side with transformer secondary conductors. Now notice again, the main is 600 amp when you review the information in the illustration. The terminals are 75 degrees C. The conductor size would make no difference because the main determines the tap due to conductors being increased for voltage drop reasons, for correction factors or adjustment factor reasons that you studied in detail in Chapter 8 if you kind of went through these chapters one by one as we're presenting them. But always keep in mind, you can call up any chapter you want to review that would help you with your design or installation if you felt like you needed help. Now notice in the step 1, we're using the 1/3 rule, not the 1/10 rule. So you take 1/3 times 600 amp overcurrent device, 200 amp. So you're actually, what you're doing, you're dividing 3 into 600 instead of 10. And 3 into 600 gives you 200 amp. Easy way to do it. Now, step 2, the 200 amp overcurrent device that is selected from the size of the wire from table 310.16 will the 200 amp device in the panel board protects those conductors from overload and protects the panel board from overload. Now in step 3, then 240.4B as in boy 2 and 240.21B to item 2 along with 240.3, which automatically tells you we're protecting equipment of that overcurrent device as well as the conductor, which would be 240.4. So the solution and answer is the size of the overcurrent device in the panel board with the tap conductors, or 3/0, would be 200 amps, and it would protect the tap conductors plus the panel board as required by 240.21B2. We're over 10 foot to 25 foot is the tap being made.